Okay, so we're now moving on to finding inequalities with binomial distribution. So what I mean by that is something like, what's the probability that x is greater than 3? What's the probability that x is less than or equal to 5? Something like that. I'm looking at the final 3 slides on the PowerPoint that I uploaded from your last lesson. And you'll see that I've given you an example of a table. Now, in your exam, your applied exam, you get given a table of cumulative distributions, probabilities from a range of sample sizes. Now, a lot of students find the tables really difficult to understand. So, although I've shown it you there as an example, I will be using the calculator for everything that I do. You are welcome to try and understand the table, but I will not be using it. Now, my calculator, because it's like a computer program, has to understand a particular input. Now, my calculator only understands something in the format of less than or equal to. So when we're doing problems like the examples we're going to do, we have to translate it into a form that it understands. So I'm going on to the second to last slide and doing that example. So it says a random variable x is binomially distributed with a sample size of 20 and a probability of 0.4. Find the probability that x is less than or equal to 7. That's great. That's in the form that my calculator understands. So, on my calculator, I'm going to go to Menu and go to number 7, Distribution, like we did last time. But this time I'm going to go down the page and go to Binomial CD. So that means Binomial Cumulative Distribution. We want the variable one at the moment. We will look at the list later, but for now we want variable. X is my less than or equal to, so 7. N is my sample size, so 20. And P, my probability, so 0.4. So the probability of 7 occurrences, given a sample size of 20 and a probability of 0.04, is 0.416 to 3 significant figures. Part B. What's the probability that x is less than 6? Now, my calculator doesn't understand this. It only understands less than or equal to. So I need to change this into a form where it's less than or equal to. Well, if I want less than 6, that means I want 5 or less. So I'm still on this screen. If I press equals, it takes me back to my input screen. So instead of 7, I'm going to put 5, press equals. So the probability of 5 or less occurrences is 0.126 to 3 significant figures. Part C, the probability that x is greater than or equal to 15. Now, all my probabilities add up to 1. So if I imagine that I've got a bar to model this, this is the point which is 15 or more, which is what I want. But what I need to tell my calculator is about this information. So this bit here that I want is 1 minus what I can tell my calculator, which is x is less than or equal to 14. So Menu, Distribution, Binomial CD, Variable. I want less than or equal to 14, which is 0.998. And I'm going to do a few significant figures so that my accuracy level is higher. So I'm going to go back to my normal calculator screen. 1 minus 0.998388. Now it comes off a standard form. So 1.61 times 10 to the minus 3 to 3 significant figures. But I can translate that to be 0.00161 in ordinary form. Now, if you are someone that can't remember quite in the panic of the exam how to translate that back, you can give your answer in the standard form. That would be acceptable if you needed to. Okay, so we're going to go on to the